If you live in the Philippines, you felt it. That sudden jolt that makes you freeze, the rumbling beneath your feet, the hanging lamps swaying, that moment of uncertainty where you wonder, should I run or will it stop? For most of the world, earthquakes are rare, catastrophic events that make international headlines. But in the Philippines, they're part of life. Small earthquakes happen almost daily. Moderate ones occur monthly, and major, destructive earthquakes strike every few years. The question isn't if the ground will shake. It's when, where, and how strong. But why? Why does the Philippines experience more earthquakes than almost anywhere else on Earth? Today, we're answering that question by taking you deep beneath the surface, into the geology that makes the Philippines one of the most seismically active countries on the planet. Because understanding why earthquakes happen here is the first step to living safely with them. The simple answer is location. The Philippines sits on the Pacific Ring of Fire, a 40,000-kilometer horseshoe-shaped zone that circles the Pacific Ocean. This ring is where about 90% of the world's earthquakes occur, and 75% of the world's active volcanoes are located. Countries on the Ring of Fire include Japan, Indonesia, Chile, New Zealand, and the Philippines. What makes this zone so active? It's where tectonic plates meet. Earth's surface isn't one solid shell. It's broken into massive pieces called tectonic plates that float on the hot, semi-liquid mantle beneath. These plates are constantly moving, slowly but relentlessly, at about the same speed your fingernails grow. When these plates interact, pulling apart, pushing together, or sliding past each other, that's where earthquakes happen. The Philippines doesn't just sit near the Ring of Fire. It sits at one of the most complex tectonic intersections on Earth. Multiple major plates converge in this region. The Philippine Sea Plate, the Eurasian Plate, the Sunda Plate, and the Pacific Plate. All of these massive pieces of the Earth's crust are moving, grinding, colliding, and the Philippines is caught in the middle. This isn't like sitting near one fault line. This is like standing at a tectonic crossroads where forces from multiple directions are constantly pushing and pulling. That's why earthquakes here are so frequent and come from so many different sources. Let's zoom in and look at the specific plate boundaries that create earthquakes in the Philippines. The most important is the Philippine Sea Plate. This oceanic plate is moving westward and northwestward. As it moves, it collides with the Eurasian Plate, which includes most of Southeast Asia. When an oceanic plate meets a continental plate, the denser oceanic plate dives beneath the lighter continental plate. This process is called subduction, and it's happening on both sides of the Philippines. On the eastern side of the country, the Philippine Sea Plate is subducting beneath the Philippine archipelago along the Philippine Trench. This trench is one of the deepest parts of the Earth's ocean, plunging over 10,000 meters below sea level. The Philippine Trench runs along the eastern coasts of Luzon, Samar, Leyte, and Mindanao. As the oceanic plate descends into the mantle, it melts, creating magma that rises to form volcanoes. This is why the eastern Philippines has so many active volcanoes. But here's where it gets complex. On the western side of the Philippines, a different subduction zone is active. The Sunda Plate, part of the Eurasian Plate system, is being subducted beneath the Philippine archipelago along the Manila Trench and Negros Trench. So the Philippines has subduction happening on both sides. It's like being squeezed between two slow-motion collisions. Both of these subduction zones generate powerful earthquakes. When the descending plate gets stuck due to friction, stress builds up over years or decades. When that stress finally releases, the result is a massive earthquake. But subduction zones aren't the only source of earthquakes in the Philippines. There are also major fault lines cutting through the islands themselves. The most significant is the Philippine Fault, a massive strike-slip fault that runs over 1,200 kilometers from northern Luzon through the Visayas and into Mindanao. Strike-slip faults are where two plates slide horizontally past each other. Think of the San Andreas Fault in California. Same mechanism. The Philippine Fault is divided into segments, and different segments can rupture independently. When they do, they produce major earthquakes. The 1990 Luzon earthquake, which killed over 1,600 people, was caused by movement along the Philippine Fault. In Metro Manila, The Philippine fault system includes the West Valley Fault and East Valley Fault, which run directly beneath the most densely populated part of the country. So to summarize, the Philippines experiences earthquakes from three main sources. First, the subduction of the Philippine Sea Plate along the eastern trenches. Second, the subduction along the western trenches. And third, movement along the Philippine Fault and other crustal faults within the islands. This combination of multiple active tectonic boundaries is why the Philippines is such a hotbed for seismic activity. It's not one fault line. It's an entire network of geological hazards all active at once. Let's talk about the numbers. The Philippine Institute of Volcanology and Seismology, PHIVOLCS, monitors earthquake activity across the country. On average, the Philippines experiences about 20 earthquakes per day. Most are too small to feel, magnitude 2 or below, but several times per week there are earthquakes strong enough that people notice them. Magnitude 4. Earthquakes happen regularly. Magnitude 5 earthquakes, which can cause minor damage, occur every few weeks. Magnitude 6 earthquakes, which can cause significant damage, happen several times per year. And magnitude 7 or larger earthquakes, which are catastrophic, strike every few years to every few decades, depending on the region. Why are some earthquakes stronger than others? It depends on how much stress has built up and how much of the fault ruptures. Imagine bending a stick. The more you bend it, the more energy is stored. When it finally snaps, all that energy releases at once. Faults work the same way. Stress builds as plates try to move past each other but get stuck by friction. Eventually, the stress exceeds the strength of the rocks, and the fault ruptures. The amount of energy released determines the magnitude. A longer rupture releases more energy, creating a stronger earthquake. The 1990 Luzon earthquake ruptured about 125 kilometers of the Philippine Fault. The energy released was equivalent to thousands of nuclear bombs. The depth of an earthquake also matters. Shallow earthquakes, those occurring within the top 70 kilometers of the Earth's crust, are the most destructive. The energy doesn't have to travel as far to reach the surface, so the shaking is more intense. Deep earthquakes, occurring 300 kilometers or more below the surface, are less damaging because the energy dissipates as it travels through rock. Most of the Philippines' destructive earthquakes are shallow, occurring along the fault lines within or just beneath the islands. But earthquakes don't just cause shaking. They trigger secondary disasters. Landslides are common, especially in the mountainous terrain that covers much of the Philippines. The 1990 Luzon earthquake triggered massive landslides that buried entire communities. The 2013 Bohol earthquake did the same. When an earthquake strikes near the coast or underwater, it can generate a tsunami. The 1976 Moro Gulf earthquake created a tsunami that killed thousands along the coast of Mindanao. And earthquakes can trigger volcanic activity. When an earthquake occurs near a volcano, it can disturb the magma chamber, potentially leading to an eruption. So given all this seismic activity, can earthquakes be predicted? The short answer is no. Scientists cannot predict the exact date, time, and location of an earthquake. What they can do is assess risk. PHIVOLCS has mapped all the major faults in the Philippines. They know which faults are most likely to rupture based on how long it's been since the last major earthquake and how much stress has accumulated. They can say, for example, that the West Valley Fault in Metro Manila is overdue for a major earthquake because it last ruptured in 1658. But they can't say it will happen next week or next year. Earthquake prediction is one of the greatest unsolved challenges in geology. What scientists can do is monitor for warning signs. Before a major earthquake, there are sometimes precursory signals. An increase in small earthquakes in a specific area. Changes in ground deformation measured by GPS, variations in groundwater levels or gas emissions. But these signals are inconsistent and don't always precede major earthquakes. And sometimes major earthquakes happen with no warning at all. That's why the Philippines relies on preparedness rather than prediction. PHIVOLCS operates a nationwide network of seismometers that detect earthquakes within seconds. When a major earthquake is detected, an earthquake early warning system can send alerts to areas that haven't felt the shaking yet. Because seismic waves travel at a finite speed, areas farther from the epicenter can receive warnings seconds to tens of seconds before the shaking arrives. It's not much time, but it's enough to drop, cover, and hold on. It's enough for trains to brake and for elevators to stop at the nearest floor. Seconds can save lives. Understanding why the Philippines is an earthquake hotspot also helps explain why the country has so many volcanoes. Subduction zones don't just produce earthquakes. They produce volcanoes. As the oceanic plate descends into the mantle, it heats up and releases water. That water lowers the melting point of the surrounding rock, creating magma. The magma is lighter than the surrounding rock, so it rises. When it reaches the surface, it erupts as a volcano. This is why the Philippines has 24 active volcanoes: Mayon, Taal, Pinatubo, Bulusan, Canlaon. All of them exist because of subduction. The same tectonic forces that create earthquakes also create volcanoes. The two hazards are linked. The Philippines also has geothermal energy potential because of this volcanic activity. The heat from magma beneath the surface can be harnessed to generate electricity. The country already operates several geothermal power plants, and this is one of the few benefits of living in a tectonically active zone. But the trade-off is constant exposure to natural hazards. So what does all this mean for people living in the Philippines? It means earthquakes are unavoidable. They're not a bug in the system. They're a feature of the geology. The Philippines exists because of tectonic activity. The islands were built by volcanic eruptions and uplifted by tectonic forces. The same processes that created the beautiful landscape also make it dangerous. You cannot live in the Philippines and avoid earthquake risk, but you can prepare. Preparation starts with understanding. Know where the major faults are. 5OLCS publishes fault maps. If you live near a fault, your risk is higher. Know what to do during an earthquake. Drop, cover, and hold on. Don't run outside. Stay away from windows. If you're driving, pull over. If you're in bed, stay there and cover your head. Have an emergency kit with water, food, first aid supplies, and a flashlight. Secure heavy furniture so it doesn't tip over during shaking, and participate in earthquake drills. The more you practice, the more automatic the response becomes. Building codes matter. Structures built to modern seismic standards can withstand strong shaking. But enforcement is inconsistent in the Philippines. Many buildings, especially older ones, are not earthquake resistant. Schools, hospitals, and homes are all at risk. Improving building standards and retrofitting vulnerable structures is one of the most effective ways to reduce earthquake deaths. But it requires political will and funding that has been lacking. The Philippines will continue to experience earthquakes for as long as the tectonic plates continue to move. And they will continue to move for billions of years. This isn't a problem that can be solved. It can only be managed. The question is whether the country will invest in the infrastructure, education, and preparedness needed to live safely with this reality. Other countries on the Ring of Fire, like Japan, have shown it's possible. Japan experiences more earthquakes than the Philippines, but deaths are far lower because of strict building codes, extensive public education, and advanced early warning systems. The Philippines can learn from that example. The ground beneath the Philippines is constantly moving. Plates are colliding, faults are slipping, and magma is rising. This makes the Philippines one of the most geologically dynamic places on Earth. It's why the country has such dramatic landscapes, fertile volcanic soil, and abundant geothermal energy. But it's also why earthquakes are part of life. Understanding the geology doesn't make earthquakes less dangerous, but it does make them less mysterious. And when you understand why the ground shakes, you can make better decisions about how to stay safe. The Philippines is a hotbed for earthquakes because of where it sits on the planet, and that won't change. What can change is how prepared people are when the shaking starts. Subscribe to this channel for more explanations of Philippine geology, earthquake science, and disaster preparedness. Because the ground will shake again. The only question is whether you'll be ready.